Okay, so good morning all. So this is a continuation class for vacuuming. So yesterday class we discussed about um, what is the MVCs in PostgreSQL. So how the transactional consistency we have. So everything we cover, right? So today we are going to cover what is the vacuuming and what type of vacuuming we have and what are the settings involved for the auto vacuuming. So what will happen exactly if you do the vacuuming. So those things we will cover and then followed by the practicals and also Darpan, you have some questions right for PG backrest. Okay, so we will answer those questions as well. Okay, so unfortunately there is a system crash for my side. So I'm connecting from mobile also. Okay, and PG backrest maybe you are correct. Okay, so we are unable to reproduce those errors. Okay, so during the same class only we need to cover those things, but due to less time frame. Okay, so even we decided, okay, so 1 hour, we will close the class by 1 hour. Okay, so okay. Yeah, vacuuming. So what exactly the vacuuming? So vacuuming is nothing but we need to remove. See, there is no undo table space management in PostgreSQL Oracle we have. So whenever if you are performing the DML operations, okay, so whenever if you're performing more DML operations, so all the pre-image data will be stored into the same table along with the live tuple. If there is a highly transactional database system, so it means the table is containing live tuples and also the table is containing the modified the pre-image data. We can call it as the tuples is nothing but like dead tuples. Okay. So the table is containing both live tuples and the dead tuples. Okay, if it is keep on growing, so the table size is trying to grow. Okay, and it is directly or indirectly is going to affect the performance of your operations if that particular a table is involved into your operation. So in this case, so PostgreSQL having the highest level of or maybe top maintenance activity that is called vacuuming. Okay, so the vacuuming is nothing but removing the dead tuples. Okay, the removing the dead tuples and freezing the transaction IDs. Okay, that actually that is the operation whenever if you perform the vacuuming operation. Okay, the backend, so it is going to remove the dead tuples and also it is going to freezing the old transaction IDs. Okay, that is associated with the dead tuples. Okay, and we have the two types of vacuuming operations. One is auto vacuuming or normal vacuuming, and second one is the full vacuuming. Okay, so auto vacuuming and normal vacuuming is nothing but from a latest version of the PostgreSQL. Okay, previously we don't have any auto vacuuming backend process or background process in PostgreSQL. Okay, so in the later versions of I think 9.6 onwards, we have exact version. We need to check. Okay, so but the later versions of the PostgreSQL we have the vacuuming background processes available. Okay, so it is similarly it is also cleaning the dead tuple, but we will cover in coming slides what is the difference between the auto vacuuming and full vacuuming. Okay, so we have the two types of operations. One is the auto vacuuming and second one is the full vacuuming. Okay, so what is the difference between the full vacuuming and auto vacuuming? We will cover in our next slides. Okay, and these are the two parameters. By default, it is on. Okay, that is auto vacuuming track count. Okay, so these are the two parameters is needed to enable the auto vacuuming, especially. Okay, anyhow full vacuuming it is we are going to do the manually or we can do the full vacuum either with any schedulers. Okay, from the cron or some relevant schedulers from the PostgreSQL we can schedule. Okay, but these are the two settings we can have to auto vacuuming in PostgreSQL. Okay, and now we can discuss about what auto vacuuming or normal vacuuming you can say. Okay, so actually this vacuuming, whenever if you perform the auto vacuuming or normal vacuuming operation, okay, so what it will do, it will remove the dead tuples. Okay, so it will remove the dead tuples and it is not going to reclaim the space into your operating system. Okay. So, but that particular space, okay, the dead tuples after removal of the dead tuples, the space will be reused. Okay. So, if suppose you perform the vacuuming operation on the particular table, and like it means the particular table is like a part of auto vacuuming operation. Okay. So, whenever the auto vacuuming is performed automatically by PostgreSQL for the particular table. Okay. So once the auto vacuuming is operation is completed on the particular table, okay, the space will not be released into the operating system. Okay, so but suppose if you are going to reinsert or if you're going to update some records into the particular table, so then what it will happen? The same space, okay, the auto vacuuming release space will be reused by the like future transactions or future use. Okay. Okay. So like as we said, like okay, so deleted or obsolete tuples. Okay, so we can call it as the like, dead tuples will be removed whenever if you perform the vacuuming operation. Either it may be auto vacuuming, either it may be the full vacuuming. Okay. So as we said, like there is no extra space is going to release into the operating system whenever if you're performing a auto vacuuming operation. Okay. So just the space will be like available for like the future reuse. Okay. And also there is a big consideration here. Okay, so whenever there is a auto vacuuming operation in either it may be even table level or maybe database level, it is automatically will trigger based on some settings. Okay, we will tell you what are the settings we have in the vacuuming operation in our next slides. Okay, so whenever the settings are like to match or whenever the settings are satisfied, okay, automatically auto vacuuming will trigger by the like auto vacuuming background process. Okay. So during the auto vacuuming process, there is no exclusive locks on the table. Okay. So we can say it is completely auto vacuum is a completely online activity. Okay. So the ongoing transactions or ongoing like operations on a particular table or database, it is not going to affect anything. Okay. So auto vacuum is completely online activity, but full vacuuming is a like offline activity. Okay. So we will cover that full vacuum slide in next slide. Okay, and like as we said, okay, whenever if you are performing like more DML operations, okay, there are like more modifications happening on your PostgreSQL system. Then those are the like see whenever if you perform the more DML operations means like the pre-image data. Okay, so if you deleted some data, okay, the deleted data will be there into your table. Okay, if you update something, okay, if you update something, okay, the updated information, okay, the pre-image data will be stored into your table itself. Okay, it means it is going to fill up with the red tuples. Okay, so it means like if you are performing the more DML operations, okay, on the particular table, so those are the best candidates. Okay, those are the best candidates for the vacuuming operation. Okay, yeah, this is about the auto vacuuming. Now next we can cover about the full vacuuming. Okay, so full vacuuming is nothing but, okay, so the full vacuuming, what exactly it will do whenever if you perform the full vacuum on the table or full vacuuming on like a database, okay. So in this situation, the entire table, okay, entire table is going to rewrite into your disk file, okay. It means whenever if you perform full vacuuming operation, okay, that time you can see the OID of the table, okay. What it will do, it is going to recreate the new table file with the new OID, okay, and it will remove the like dead tuples from that particular OID, okay, and there is exclusive lock during this full vacuuming operation. That particular table is like not accessible, okay, for the during the vacuuming operation, okay. It means what exactly it will do, it will like it is kind of re-indexing, okay, or index. We will do the like rebuild index right in the PostgreSQL, okay. So what it will do exactly, it will create, okay, or it will create like a similar kind of index, or maybe this way we can tell like in Oracle the DBMS and underscore redefinition. Okay, if you want to defragment your table, okay, in the situation backend, what it will happen, okay. So during the full vacuuming operation, also the same concept internally it will use by the PostgreSQL. It is going to recreate your table, okay, with the OID, another OID, okay, and it will perform the like removal of all your dead tuples, okay, So during the vacuuming operation, during the full vacuuming operation, due to this recreating of the new disk file or maybe a real file node, okay, so if they, maybe the table size is 1 TB, so then you need to have, okay, you need to have or you need to consider, so you need another 1 TB size, one or 1 TB space or 1 TB free space into your storage location to hold this new temporary table, okay. So this is like the full vacuuming will do. So what exactly, what are the other things also the full vacuuming do? Okay, so it is going to reclaim, okay, it is going to reclaim the space into your operating system level, okay. So, and also one more thing is the full vacuuming operation, okay. So you need to consider this is complete downtime for like maybe if you are performing full vacuuming on the table, so that particular table is not accessible during the full vacuuming operation. And if you are like performing, okay, if you're performing like vacuuming, full vacuuming at the database level, okay, that particular database is not accessible during the full vacuuming operation. So it means it is containing like exclusive locks on the table or database, okay, while you are performing the full vacuuming, okay, and also the full vacuuming is like taking the like we can say more time to complete the vacuuming operation. Why? Because backend these many operations will happen. Okay, it means full vacuuming. It will rewrite into the new disk file. Okay, and it is removing the dead tuples. Okay, and also it is going to perform. Okay, it is going to perform the analyze of your database, analyze of your table. It means like it is going to gather the statistics. Okay, gather the statistics of your table or a database. Okay, and what else we have here? Okay, and full vacuuming, like we have a utility called like vacuuming DB. Okay, this is to perform the like full vacuum for the database level. Okay, so during the like vacuuming DB operation, it is going to remove the dead tuples, and also it is going to analyze your entire database related objects. Okay, it means it is going to gather the statistics of like your database or your like a table. Okay, but here vacuum DB, this is specifically for a database level. Okay, and one more important thing is it is going to update. Okay, it is going to update the free space map and visibility map. Okay, so you know, right? Okay, so in the later versions of the PostgreSQL, okay, the visibility map is like coming into the picture. Okay, this visibility map is like it is going to improve. Okay, it is going to improve the performance of the vacuuming operation. Okay, suppose if you maybe dig something about visibility map. Okay, the free space map anyhow, so it is containing the how much of the free space is available into your pages. Okay, so it is going to update into the each page header. Okay, but visibility map is like useful for vacuuming operation. Okay, so during the vacuuming operation, visibility map, what it will do, so it is going to, okay, it is going to read. Okay, it is going to read the each page. Okay, it is going to read each page like it containing the information. Okay, it containing the information where exactly suppose my table is like 1 TB of my table. Okay, and in the 1 TB like 8 KB of the pages. Okay, so 8 KB of the pages is there to store the actual data. Okay, not each page is holding the dead tuple, right? Okay, suppose 1 TB of or maybe we can consider like I have the 10,000 pages. Okay, for a particular the page, sorry, a particular table. Okay, I need to perform the vacuuming operation for the particular table related 10,000 pages. Okay, in this situation, not all 10,000 pages is going to hold or is going to have the dead tuples. Okay, might be 2,000 pages. Okay, or 2,000 pages having the dead tuples. Okay, in the previous versions of the PostgreSQL, whenever if you perform the vacuuming operation, okay, there is no visibility map concept in PostgreSQL. Okay, so what it will do, so instead of like removing the dead tuples for 2,000 related pages, okay, so before the visibility map concept, okay, it is going to scan, okay, it is going to scan entire 10,000 related pages, okay, and then it is going to perform the vacuuming operation in PostgreSQL, older versions of the PostgreSQL. But whenever the visibility map is like introduced by the PostgreSQL community or vanilla flavor of the PostgreSQL organization, Okay, so the visibility map, okay, visibility map is directly or indirectly, it is going to improve, okay, the performance of your the vacuuming operation by skipping the pages which are not having the dead tuples. Okay, it means it is going to consider only the pages which are having the dead tuples. Okay, and it is maintaining in the visibility map. Okay, and those pages are the good candidates, and those pages are like included. And those pages only scan during the vacuuming operation. Okay, this is the one consideration. This is the one advantage with help of the visibility map in PostgreSQL later version. Okay, so once the vacuuming operation is completed, okay, so vacuuming operation responsibility to update, okay, FSM and VM related information, okay, into the each page headers, okay. Then next during our next vacuuming operation, okay, it will consider, these particular pages are having the data pools, and okay, and this particular page having the actual space, okay, actual free space, okay, and based on that, the pages will be available for our future operations. Either it may be insert or either it may be update operations. Okay, this is about the full vacuuming. Any doubt with a normal vacuuming and full vacuuming, guys?
I have a question in the first slide.
Yeah.
Yeah. What does freezing old transaction exactly means?
Yeah, so basically what it do, it will check the old transaction ID data tuples and it will reuse for the future use. So there is one parameter called, okay, let me come back to the yesterday's slides. Okay, so here we have a parameter called vacuum freeze minimum age. Okay, so whenever this minimum age, which means 50 million transaction reaches. So what this vacuuming do, it will check for that parameter. If that reaches, then it will do the freeze operation, which means the old transaction IDs, the past transaction IDs will be used for the future. So that operation will also taken care by vacuuming.
Okay, thank you.
Yeah.
Yeah. Okay, so that is about like vacuuming and full vacuuming. These are the settings. Okay, so actually these are the by default settings by the PostgreSQL, and also these are the, we can say, the recommended settings. But again, okay, based on our requirement and based on like how much the transaction is happening in our PostgreSQL system. Okay, so you can change these settings to like aggressive our auto vacuuming operations. Okay. So you can see here during the vacuuming operations, two things will happen. Okay. So or maybe we can say the auto vacuuming and auto analyze. Okay. We can say these two things will happen internally with help of these settings. Okay. And this is the formula. What is the auto analyze? Auto analyze is nothing but like gathering the statistics of your the PostgreSQL cluster. Okay. So here the auto analyze scale factor into number of tuples in our PostgreSQL table, okay, plus auto analyze threshold value. Here you can see auto analyze, okay, auto analyze scale factor is 0.1, okay, by default value, and the auto analyze threshold is 50, okay. So whenever the table is like having, okay, the table is like having or satisfied this particular formula, okay, automatically your table is like part of, or it is the auto analyze or like auto vacuuming, okay, operation will automatically trigger. Okay, auto vacuuming, the formula is something like this. Okay, vacuum scale factor into number of tuples, okay, plus auto vacuuming threshold. Okay, you can see here auto vacuuming scale factor is 0.2 and threshold is 50. Okay, so here you can see, suppose if you consider like maybe my table is having the 1000 records. Okay, so in this case auto vacuuming, so when it will trigger automatically, suppose in your particular table 250, okay, 1/4 of like your table is having, okay, the dead tuples, automatically auto vacuuming will trigger. Okay, and when the auto analyze will trigger, okay, suppose there is like 150 like tuples, it is changed. Okay, in this situation automatically the statistics will gather for the particular table. Okay, and these changes, like you can change. Okay, these are the default changes. Okay, but these particular scale factor related to vacuuming and the analyze. Okay, and the threshold related to vacuuming analyze. Okay, those things will be changed. Okay, those things will be changed, and those things will be like manage, okay, as per your requirement, okay, based on your like how many transactions you have and how frequently you want to have like vacuuming, and how frequently you want to have a like analyze operation in your system. Okay, you can change it, but suppose if I change our scale factor and also auto vacuum threshold, scale factor is like vacuuming scale factor is like instead of 0.2, if I change to 0, and then auto vacuuming threshold also instead of like 50 rows, I change to 1000. Okay, then you can see if you apply these particular values, then every 100 dead tuples, okay, so every 100 dead tuples, okay, so automatically the vacuuming operation will trigger. Okay, so like this, even we can change with help of the alter table set the threshold values. Okay, we can change it for the particular table. Okay, even we can change it for even for the database level as well. Okay, so the based on the threshold, okay, it make no sense like if you change the values for the database level. Why? Because it is already applicable, okay, for like the tables which are frequently accessing, frequently having the more DML operations. Okay, so based on the satisfaction of this particular formula, okay, it is automatically vacuuming operation will trigger on particular tables. Yeah. Any doubts in with this particular slide? Okay. Okay, so then, so what are the like maybe considerations we have, or maybe what are the things are stopping the vacuuming operation? Okay, in the Postgres SQL. Okay, and the first consideration is like long running transactions. Okay, if suppose the transactions are like it is running for the long, okay, and maybe the during the same operation time, long running transaction is in progress, and the same time vacuuming also trigger, okay, auto vacuuming also trigger. Okay, so then what it will happen, okay, so the auto vacuuming operation will not consider, okay, the particular transaction related tables into the vacuuming operation. Okay, it is simply skip that operation. Okay, and then the particular like maybe the particular table or maybe the set of the tables are part of the particular operation. Okay, those are not part of the like vacuuming operation during the particular auto triggering time. Okay, but the thing is, if it is keep on skipping, or it is keep on running for the like hours time, okay, maybe hours time, but during the operation, during the vacuuming operation, those are like frequently not part of our the particular vacuuming operation. So what it will happen, the dead tuples on the particular operation related tables, okay, so it is keep on increasing. Okay, then it is going to affect, okay, it is going to affect the like performance of your particular tables or set of tables. Okay, so by skipping the vacuuming operation, okay, this is one consideration. Okay, and next thing is like if there is a like a high amount of like update operations is happening on our system. Okay, so those particular transactions, okay, those particular transactions might not be included, okay, might not be included into the vacuuming operation if it is like frequently updated and like without any like control commit block. Okay, so if it means there is a high number of update operations is happening. Okay, and there is no like you are controlling this update of operation related the things instead of auto commit, you are maybe controlling with PLSQL or sorry PGSQL block from the Postgres SQL side, from application side, or maybe like AppDBA side, or maybe DBA side. Okay, in the situation, even those transaction related tables also, okay, it is not going to part of the vacuuming operation. Okay, that is also maybe stop the vacuuming operation related to the particular tables. Okay, so for maybe if there is a like share lock, or maybe concurrent foreign key checks on your tables, okay, or maybe the reference tables. Okay, those particular tables related things also will cause, okay, the freezing problems in the Postgres SQL vacuuming operation. Okay, so these are the like we can say three considerations in the vacuuming operation. Okay, and next thing is just to summarize. Okay, just to summarize, like what is the vacuuming operation? Okay, and we know like what exactly the vacuuming operation will do. One thing is like first thing, it is going to remove the dead tuples, and the second thing is it is going to free the old transaction IDs. Okay, so for the transactions which are already like removed. Okay, so those tuples, okay, the transaction IDs will be freed, and these things will be reusable for like your future transactions. Okay. And next thing is like it is going to update. Okay, it is going to update the FSM and the VMs. Okay, these are the very important. Okay, otherwise if it is not updating FSM and VM values, okay, so next time if there is a like vacuuming operation is happening, okay, those pages, okay, those pages again will be part of the vacuuming operation. Okay, so it is going to affect the vacuuming operation since these things, okay, these things already considered for like our previous operations. So that is the reason like so whenever the vacuuming operation is happening, okay, or happened, so FSM and VM, okay, this information should be updated into each page headers. Okay, so and also during the vacuuming operations, okay, there is a like statistics will be gathered. Okay, and the statistics information will be stored. Okay, the statistics information will be stored or will be updated into PG stat tables. Okay, so based on this particular table related statistics, okay, the table related history of the statistics, okay, optimizer will pick the best execution plan. Okay, so and also the best consideration and also the important thing is, okay, you need to have the monitoring of your PostgreSQL at least like alert log. Okay, alert log is like having, okay, so when exactly like vacuuming is going to perform, okay, how many transaction IDs are like pending. Okay, so those alerts is going to trigger those alert warnings will be having in the your PostgreSQL alert log file. Okay, so it is very important to have the monitoring. Okay, it is very important to have the monitoring of your transaction IDs. Okay, and also it is, we can say, the proactive monitoring to like avoid unnecessary like your database or table into the like hung state by running the like auto vacuuming. Okay, auto vacuuming in the sense like not like auto vacuuming the PostgreSQL. Okay, if whenever the transaction IDs reaches a maximum value, okay, then automatically the system will be into hung mode. Okay, the application is unable to access the like the PostgreSQL database instances. Okay, so then what it will happen, it is forcefully is going to perform the full vacuuming operation. Okay, so as we said, the full vacuuming is nothing but it is going to consume. Okay, it is going to consume or it is going to have the exclusive lock on the table. If it is performing the table level, it is going to perform on the like database level. Okay, so the database is not going to accessible for the application team. So that is the reason. Okay, it is keep on throwing the warning message into PostgreSQL. Okay, so how many where you are on like transaction IDs, how many transaction IDs left. Okay, so when exactly the vacuuming may be triggered. Okay, those information is keep on getting the warnings in the alert log file. That is the reason you can have the like monitoring for your PostgreSQL alert log file to avoid those kind of situations. Okay, yeah, this is about the vacuuming. Okay, we can jump into the practicals now. Any doubts, team?
In your
One
last
question.
slide, yeah, please go ahead.
Go ahead. I will ask my question after you are done.
Okay. So this remove unnecessary parts of C log if possible. What is this?
Yeah, this is actually C log is nothing but the committed log. Okay, so actually the committed log. Okay, so the transactional related. Okay, the transaction related committed tracking. Okay, it is going to store into the C log. C log is nothing but the committed log. Okay, to maintain the data consistency or to maintain the transactional consistency. Okay, so in the PostgreSQL we have the committed log. Okay, it is containing the particular operation. Okay, the particular operation is committed or not. Okay, and so it is managed internally. Okay, but we can say in the direct answer to your question, it is containing the committed of your transactions, okay, to maintain the transactional consistency, okay. So during the vacuuming operation, what it will do, so the transactions, okay, the transactions already committed, that note of that information is available into the committed log, okay. It is going to do the cleanup, okay. It is going to clean up, or it is going to like remove the like unnecessary information into the committed log. Okay, that is the one. Darpan, I think Darpan, right, asked this question.
Yeah.
Yeah.
Okay. Thank you.
Yeah, Malati, please go ahead.
Yeah, with reference to this warning messages in the alert log, does it provide information like so much percentage of free space or dead tuples available? What kind of warning messages does it provide?
You can see here, you can see our screen now, okay, in the red color. Okay. So database, that is the Finland is the one database, must be vacuuming within these many transactions. Okay. It means you are able to do the, like you can connect, okay, and you can perform the transactions, these many transactions, okay, you can do it, okay. But after that, okay, if you are not, maybe if you turn off your auto vacuuming, okay, if you turn off your auto vacuuming, then automatically full vacuuming will trigger and our system into the hung status. Okay, like this it will provide. Okay, it will provide the warning message. These many transactions. Okay, so we have left in our system. Okay, so must be vacuuming. Okay, must be vacuuming within the particular range. Okay, otherwise if it is beyond 32, maybe it is reached 32 value, 532 value. Okay, then automatically it will into the like full vacuuming status. Okay, so like as a DBA we should have this monitoring, and we can avoid, or we can like perform, okay, with help of the application team, we can take the downtime. Okay, if maybe there is an issue with the auto vacuuming, it is not cleaning up proper transaction IDs, it is not cleaning up your dead tuples. Okay, in this situation you need to inform application team. So guys, like we are going to have the like maintenance activity, okay, take any off business hours, okay, and perform the vacuuming operation. Okay, so this is the kind of like alert we will get at. Okay, based on that we need to react.
Okay.
Yeah, is there a view where we can find when was last vacuum and analyze them?
Yes,
So
we have that. We will cover in the practical. Okay, so basically here, if you see the transaction ID is 2.1 is for past and 2.1 is for future. So whenever it reaches half of the transaction IDs, which is 1 billion, you will get a warning message like this. Okay, so it's keep on coming your warning messages. And anyhow, auto vacuum process will take care whenever the limit is reached, right? So this limit is reached, 50 million transactions. But few times because of your table is busy, it may skip to do vacuuming. In that cases, as a DBA, we have to monitor and we have to do it as soon as possible. Okay, so this value we have to check, and if it reaches, it is coming to reach 2.1 billion, then we have to take care of that vacuuming. Yeah. So let's do a practical.
Yeah, correct. Yeah, we can continue with the particles. And also one more consideration, maybe you can see, so why we have the data pulse, why we have these many like maybe maintenance activity in the Postgres SQL. Okay, maybe this is the disadvantage in the Postgres SQL, we can say. Okay, but it is keep on improving. Okay, the vanilla or maybe the community of the Postgres SQL. Okay, they are keep on working on like improving the functionalities of all these things. Okay, so maybe later version of our Postgres SQL, either maybe as we said from the beginning. Okay, the Postgres SQL 17 is the one benchmark we can say in the Postgres SQL maybe the journey. Okay. We can expect some good things on even the vacuuming. Okay, so maybe in the real-time systems, you can say this is one of the painful activity. So if your system is like maybe very critical one, okay, so maybe we can expect, okay, in the 17 onwards, there is a like huge amount of like improvements on even the maintenance activity as well. Okay. And there is a like maybe we can say in the later versions of, or maybe we can say even I think maybe 14 or 13 hours. Okay, there is an online activity as well for the PG_repack. Okay, that is the one activity to perform. Okay, the vacuuming operation and online on the real-time system. Okay, so Okay, so like that, that is extensions we can create. Okay, and that is developed by some other maybe the other maybe the persons or other organizations. Okay, so like that we have like different like improvements is coming in future. We may expect. Okay, in future we may expect the good things for even the vacuuming operation. Since this is a very big maintenance activity in the PostgreSQL, maybe this is one kind of even drawback. And also, but there is no undo table space management to like reset your pre-image data. So there is no other way, but we may have something in the future. Yeah, we can continue the practicals now. Yeah.
Yeah. So probably if your system is very critical and so application team is not giving downtime to do a full vacuuming, so you have an option called PG repack where you can do the vacuuming in online. So now first we can understand the transaction IDs and how the system columns, okay, how we can see the system columns of a table. So based on the operations which you are performing. So we'll see first these things. Okay, so first I'm trying to create a test table. Okay, and I'm going to insert a record. Okay, so currently I have this record in my table. Okay, so now apart from this, if you see, you have two columns, right? So one is ID and others is name, right? So we have two columns. Apart from these two columns, you also have system columns. Okay, so we have a view called PG underscore attribute. So with the help of that view, you can able to identify what are the system columns we have under this table. Okay, for example, if you see, these are the two original columns we have. Apart from this, we also have 6 system columns. One is table OID, CMAX, XMAX, okay, and we also have XMIN, okay, and we have CTID. These are the 6 system columns. Okay, among these, XMIN and XMAX are the main two important system columns. MVCC will use these two system columns, and it will do the consistency whenever you do multiple operations. Okay, your consistency will be managed with by MVCC, and it will, based on these two values only, it will maintain, or it will fetch the details, the transaction IDs. Okay, so for example, if I want to know what is my current transaction ID, so currently this is my transaction ID, okay, 900. Okay, now I want to fetch what is the transaction ID for XMIN and XMAX for this table. For example, I want XMIN, XMAX, and CTID from test. Okay, I don't want only system columns. I also want all details from test. So if you not explicitly mention the system columns, when you do select start from this table, by default you will get your original data. Okay, to get your system columns, you have to explicitly mention the system column value. Okay, if you see, XMIN is updated as 899. Okay, because this is the current transaction ID. And whenever you are doing the update operation, that time it has allocated the current transaction ID to XMIN. And XMAX remains 0 because you are doing an insert operations, right? When you do an insert operation, your XMIN value will be updated and XMAX will remain 0. Okay, and this is the CTID. So 0 is the page number. Currently, this data resides on the page 0 and line pointer 1. Okay, because this is the first record and the line pointer is 1 and the value is 100 and stayouts. Okay, now let me do an okay, instead of insert, let's do an update statement. Okay, because Postgres is auto commit, what I'm doing an update operation in the begin class. Okay, so that I can control the commit and rollback with in the PG SQL block. Okay, so now I want to update the name to a different value. Okay, where the ID equal to 100. So what I'm trying to do is update test set name equal to, maybe I will update like Oracle, okay, where ID equal to 100. Okay, still I haven't committed the transaction. I've just updated this particular record. Okay, now let's check what is the xmin and xmax value for this particular table. Okay, now if you see, I have did an update statement. Okay, and I fetch the system columns. What it does, it creates its own snapshot. Okay, this is the previous snapshot. 0, 1 is the CTID, and the xmin is 899. And now xmin is 901, and it has migrated the entire row from this snapshot to this snapshot, right? And it has updated value Oracle, and it has migrated the value from 01 to 02, and xmin value is 901. Okay, now let's go to the other session. Okay, so P-SQL. And let's run the same query here. Select xmin and xmax from test. If you see, still the data which we are trying to fetch is the previous image, right? Because this session is not committed. In this particular session, it is creating its own snapshot, and in this session it is visible a new snapshot. But when you check the other session, okay, it is still the previous image. If you see, the ID is 100 and the name is Kayubs, right? And the CTID, it is still pointing to 01, okay? And xmin is 899, and it also displays the xmax. Okay? If you see, it also updates the xmax. Whenever you do an update statement or delete statement, xmax value will be allocated. Okay. So if you see the xmax value, which means it is trying to modify your blocks. Okay, some other session is trying to modify your blocks, and this xmin value is less than xmax. Okay, then you have to think like it is doing some operation from other session. Okay, that is the xmax value. Okay, so once you do a commit here, and when you check the data xmin and xmax, now it has already committed, and anyhow it will display the new snapshot. Okay, but from the other session, whenever you try to fetch, even they will also get the new snapshot. Okay, how they will get? Because the other transaction is already committed, serializable isolation algorithm, what it will do, it will make sure that the other sessions also have the same snapshots. Okay, the latest snapshot. Now the latest snapshot is available, and xmin will become 901 and xmax remains 0. Okay, if it's already committed.
You can see here actually in the above, okay, 899, 901, okay. So whenever like in another session, the select operation happened, and another session there is update statement without any commit. Okay, xmin value is, you can see the value is 899 is like the snapshot or maybe the transaction ID. Okay, for we can say the older or pre-image. Okay, so and also as like Suresh said, okay, xmax value, okay, that is related to the update related transaction ID. Okay, it means you are getting the information from the 899 transaction ID. Okay, the to maintain the consistency of your transaction related data, and also it is providing the information like there is some modification is happening. Okay, from where we can get it from xmax related value. If there is a value, there are some DML operation is going on in our particular database, particular table from another transactions. Okay, but whenever there is a commit operation is happen, okay, 899, okay, 899 is no more, it is become the dead. Okay.
Yeah. So similarly, we can also see one example for delete operation. Okay. So whenever you are not doing this in the begin section, so basically what it does is it will automatically commits. Okay. Since to understand better, I have started in the begin class just to show you how the xmax and xmin will be allocated. So whenever you do insert operations, your xmin value will be allocated, and x max remains 0. Okay, and whenever you do any update or delete operation, your x max value will be allocated until you do a commit. Okay, if you are doing any modifications, it may be update or delete. Okay, x max value will be allocated. Okay, you can see that from other session. Okay, so until it commits, okay, your x max remains a transaction ID. Once it's committed, your x max becomes 0. Okay. Now let's do a delete operation. For example, I'm trying to delete from test where ID equal to 100. Okay, still I haven't committed. Now let's go and see what values it has updated. Now if you see, you don't see any values because you are doing a delete operation, right? So delete means it is deleting that record, right? Into the new snapshot. So this version, it's trying to delete, okay, but still not committed. If you see the same from other session, you could able to see that version. So you could see this particular version is available from the other session, but in this session, still not committed. You are doing a delete operation. Since you did a delete, there is no values. This version itself you are going to delete, right? It marked as a date tuples, right? So here, but from other session, you could able to see the x max is allocated. So if your x max is allocated, what you have to think is this particular ID row, okay, this particular version of row is doing some operation by other, so other transaction. It may be update or delete operation. Okay, so now once I do a commit, okay, anyhow we don't see any data, and here also we don't see any data, right? And that particular record is deleted from the table. Okay, and it marked as a date tuple. Okay, it's no longer visible for us. Okay, but we have a view where we can identify how many date tuples we have and how many live tuples we have. pg underscore stat underscore all tables. Okay, so we have a view called relation name, live tuples and date tuples. Okay, from pg stat all tables where relation name equal to test. Okay, if you see for test, we have 0 live tuples, but we have 2 date tuples. How 2 date tuples came here? Because we did only one delete, right? How 2 date tuples it is showing? Because update is nothing but insert and delete, right? Even that also marked as old snapshot. It considers as a date tuples. Okay, so we did one update operation. For update also, it is generating the undo pre-image data, and for delete also it has generated, which means 2 date tuples are even storing in the same table, which is called test, but that data we cannot able to, it is not able to visible. Okay, but we can able to identify how many date tuples we have in this particular table. Okay, with this, and even if you have page inspect extension, let me see if we have, yeah, we have page inspect extension. Okay, with the help of this extension also, you could able to identify with row header. Okay, for example, I want xmin, xmax heap underscore page items. Okay. We have a function called get draw page for test table, and I want to fetch 0 page. Okay, so even you can find instead of this star we can use it. Okay, if you see, so from with this page header also you could able to identify, okay, this is the line pointer 1, okay, and this is the xmin and xmax values, and this is a CTID, okay, and here also we have xmin and xmax values, okay, and this is the length of your data, okay, and this is a CTID. So with the help of with the help of this we already seen in while while we are doing internals of page, right? How we can read the row header, okay? And row header has this information called xmax and xmin and CTID, right? So even from here, you could able to see the previous versions, just information like what is the transaction minimum transaction ID and what is the maximum transaction ID, those details. Okay. Now, if I want to find out what is the age of my transaction IDs, okay, and currently which transaction frozen XID we have. Okay, so we can check at the database level, pg_database. So I can check the database name, and we have frozen transaction ID, and we can also check the age from pg_database. Okay, here you could see the current age is 187. Okay, the transaction frozen XID, which means up to 715. Okay, whatever the transactions which generated, it is using for the future. Okay, and currently the frozen value is 716. Up to 715, whatever the transaction ID is generated, it's already used for the future. Okay, still we are under 187. So this value has to be reached 2.1 billion. Okay, whenever it reaches 2.1 billion of this transaction ID, then you will have an issue. Okay, it's currently still 187, and anyhow you already used almost 715 for the future. Okay, you don't have much because this is a test environment, right? You don't see much value, but in real time you could see this age value still more values. Okay, maybe in the lags. Okay. So any questions up to here? How to identify Xmin and Xmax value, and how we can check the frozen transaction IDs, and currently what is the age of the transaction ID per database. Okay, currently it is 187. Any questions? So that we can jump into vacuuming. Okay, so
maybe like Suresh, like maybe we can close for today. So it's already 7.
Yeah, we can close for today.
Yeah, and also we can we can take it out last week questions by
Yes.
I think that part.
Yeah. So your question is how we can remove the archives, right? The old archives. So basically what happens whenever you perform any okay, so my database is in archelog mode. So whenever you take any backups, as usual, so backup, before that backup, whatever the archives it's generated, it will delete automatically. Okay. And if you want to perform the cleanup, okay, already backup is taking care of deleting the archives. But if you want to explicitly delete those archives, we have a command called pg archive cleanup. Okay. So with the help of pg archive cleanup, you can able to clear the archives. So for example, in this location, my archives is saving, right? So let me go to this location, and I have this many archive logs. Okay. And if you see, it is already generating a file called with backup, which means until this particular archives, you have the backup, and the next backup until here. Okay. And the next backup until here. So this many backups I have to, so this many dot backup file is created. Okay. In the archive destination. Okay, if you want to clean up, for example, I don't want the archives, this many archives, okay, because I have this full backup and I don't want these many archives. If I want to clean those archives, you can just use this pg archive cleanup command, and you have to specify until which backup you don't need the archives. Okay, so for example, pg_archive cleanup, and if you just mention this backup file, it will clean. Okay, okay, so maybe some syntax issue. Let's go and do the help command. The pg archive cleanup removes the old WAL files from the PostgreSQL archives. Okay. And if you want to specify from which archive you want to delete, okay, for example, here you could see they have given an example. So this is archive cleanup. And what is our archive location? Our archive location is this one. And until which backup file you have to delete. Okay, maybe I want to delete until here, 7C. Okay, until 7C, it should clear. Okay, let me add the 7C and let me do an enter. Okay, it has cleaned. Now let me do ls minus ltr. You could see it has cleared until 7c, right? Now you have only this many archives. Okay, with the help of this pg archive cleanup, you can able to clean. And this is, you have to take care whenever you have, anyhow, whenever you do a backup, so previous archives it will delete. Okay, but you have a situation like your archives is getting full, you can use this pg archive cleanup until which backup you have to clear. The archives, you have to just specify that backup file. It will clear all the archives. Okay, and if you have a replication setup in place, okay, so you have a parameter called archive cleanup command. Okay, so we have a parameter called archive cleanup command. Here you have to specify the, come here. Yeah, you see here, they have given a parameter called archive cleanup command. Okay, in this command, you have to specify the pg archive cleanup utility in this parameter, and you have to specify the archive destination path. Okay, so that once your archive is applied in the standby, automatically it will clear the archives with the help of the pg archive cleanup command. Okay, so you have to specify this parameter. This parameter value which you have to set up is this one, pg archive cleanup, and this one. Anyhow, this we are going to cover in the replication class, how we can set up the this particular parameter. Okay, so when you set this, this cleanup command will automatically take care of whether your archive is already applied in the standby instance. If it is applied, then it will clear. If it not applied, then it will hold the archives. Okay, it's keep on holding. If your standby is out of sync, it won't clear the archives. Okay, and in the replication setup, you have to set this parameter. Okay, this is how you can manage the archives with the help of pg archive command. You can clear the archives.
Yeah,
Darpan,
so you
there
mentioned
is a
that,
question. Darpan, there is a one more question, right? Backup retention based on that.
no, one second. I have a question regarding the explanation.
Mm-hmm.
Yeah, so what you just mentioned is that when you do a backup, archives will be deleted, right? So in this case, we have archives before the backup also. So that is not true, right?
Come again, please.
All right, can you go to your very first output in the screen with archives? Now, okay, well, any of the backup log, right, which says dot backup, before that also we have archives. So how is backup handling deletion of archive logs?
No,
See,
archives will be
back.
present. Yeah, Raj, go ahead.
Yeah, see, actually, Darpan, okay, so during the backup, okay, so during the backup, as we said, in the PostgreSQL, we don't have any separate archive log backup, okay, first thing, okay, and second thing is the deletion of the archives, okay, so what it will do, if you see, so we are unable to like reproduce that error, okay, or maybe the log file, okay, and Suresh, do you have PG backlash in your system? I don't think so. You have, right?
Yeah, I don't have it.
Okay. Otherwise, we can reproduce the backup and backup log.
No, it is not even about reproducing. What you just said is archive deletion will be taken care of during backup, right?
Yes, exactly.
So after so many backups, we still have previous archives. So which is contradicting.
Exactly.
No, what?
See,
no.
See, the thing is definitely each during each backup, either it may be full backup, either it may be incremental backup. Maybe I'm talking about the PG backlash, or maybe if you're considering like the base backup, okay, if you take the backup, okay, so once you take the backup, okay, so the archives which are included already in the backup, okay, those archives, and there is no replication setup in your place, okay. So in this case, automatically PostgreSQL will manage to delete your archives which are already included in our like backup. Okay, that is the one thing. Okay, now you can ask what is the question next.
Yeah. Okay. Let me ask you this. What does dot backup mean?
Dot backup.
That means it has been backed up.
See.
Yes, exactly.
So before that also, if you see, there are number of archive logs, right, which have not been deleted, and we had to do that manually in the very first
Okay.
output.
Darpan, you do one thing. You just try to take multiple backups and you just try to monitor, and we can discuss this tomorrow. Okay, because once you do practice, then you will understand. Okay, so
No,
if
it is
it's
about, no, see, it is about a simple theory question to you. Initially, in your explanation, you said when you do a backup, the archives will be cleared. And in your output, I see a lot of archive logs.
no,
Before the backup also.
You just monitor the video of the PG based backup what we have discussed. That time even I have shown you the previous archives it has deleted. Okay, you just look at that video. Okay, you will understand.
Okay.
Yeah. Okay, so that's it we have for today. Probably we can catch tomorrow regarding the vacuuming.
Yeah, and Darpan, I think we left with some of the questions from your side. Just a second. What else we have on the Darpan side? I don't know. Okay, 1 second. The first question is related to backup retention based on the time. Okay, so yes, backup retention is not based on the time. First thing, okay, it is based on the the retention period. Okay, so in the stanza, okay, in the stanza file we created, it's not stanza file, we can say pg backrest.conf file. Okay, there we need to mention how many backups, okay, how many full backups we need to hold, how many incremental backups we need to hold. Okay, based on that, okay, whenever if you're performing the backup operation, okay, so whenever it is become the absolute, so the backups is automatically will delete it. Okay, so it is clear, Darpan, the first question.
Yeah.
Okay, and second question, as we discussed, okay, just you can do the practice, archives will be cleared, okay, archives will be cleared even if you see the log of the archive, okay, so from where the backup is taking and which archives are deleted, okay, so everything you will get it in the same screen, okay, if you are using console or if you are using the log info, okay, so there you will get the clear messages, okay. And the next thing is archive deletion, how it is deleted, that is already cleared by Suresh just now. Okay, and can we restore to other directory? Yes, we can restore to other directory. Okay, so that steps we will provide to you. Okay, so you can restore into in the real-time systems. Definitely we are going to restore into same system if you don't have any other system into the different directory, or maybe you can use a different system that we already shown, right? How we can, no, I think that we can do it. That we can do. I think we don't have capability to do that one. Okay, for the PG backrest due to the limitation of the systems. Okay, but the different directory, okay, we can do that. Okay, with the help of the PG backrest. Okay, so there is a command like -db something. Okay, there are some commands, and we during this different directory restore, we need to take care about the remap table space. Okay, so that we will provide the steps. Okay, so we want to show the same thing, but my system got crashed. Okay. So maybe if we install today in Suresh system, we will show tomorrow. Otherwise, we will provide the command. That is a straightforward command. Okay, so you don't need to worry about that. Okay. So any doubts? Any further doubts, Darpan or anyone?
I'm good.
Okay. Then if there is no doubts, maybe we can close the class for today.
Okay, then thank you all. Bye.
Yeah. Thank you. Bye.